Okay, this is the P3 paper from June 2023. It's question number 2. As we can see by looking at it, this is an exponentials and logs question. In particular, we're going to be looking at logs and nonlinear data. So let's have a look at the question and see what we've got. It says, figure 1 shows a linear relationship between log to the base 6 of t and log to the base 6 of x here. And then it says the line passes through the points 0, 4 and 2, 0. Can we find an equation which links log 6t and log 6x? Well, actually, absolutely we can. If we look at part A, then if it's a linear relationship, then the most famous linear relationship I know is y equals mx plus c, where in this case, y is going to be our log 6 to the t, x is going to be our log 6 to the x. But what we can do very quickly is we can work out what m and c are from the diagram that we've got up here. So if we try and work out m, looking at my diagram here, I've got 4 divided by 2, and I can see obviously it's a negative gradient, so m is going to be minus 4 over 2, which is minus 2. C up there is just equal to 4. C is equal to 4. So if I want to write this, then I'm just going to say log to the 6 base 2, log to the base 6t is equal to m, which is minus 2 log 6x plus 4. So there's the linear equation, but represented in terms of the logs from that diagram. Part 2, hence find the exact value of t when x equals 216. Well, that's nice and easy as well. That's just going to be putting that value in. So we know that x equals 216. So I'm going to get log to the base 6t is equal to minus 2 log 6 216 plus 4. And if I do that, I get that log 6t is equal to minus 2 lots of, that's 3 there, plus 4. So that all works out that log 6t just works out to be equal to minus 2. And then we use this idea that log a b equals c. If we have that log statement, we can change it into a power statement. The base stays the same, a logarithm is a power. So we can have that equivalency there. So in this particular case, we get that 6 to the minus 2 is equal to t, or in other words, t is equal to 1 over 36. Let's just go back and check. They said the exact value, yeah, so leave that as the fraction there. And then the last part says find an equation not involving logs to link t with x. I'm going to take the unusual step of doing it 2 different ways just to show you there's lots of ways we can solve these log equations. So if I've got log to the base 6t equals minus 2 log 6x plus 4 here, lots of different ways of doing it. The first way I'm going to do it is basically changing 4 and making 4 a log to the base 6 of something. So if I want to do that, if 4 is equal to log to the base 6 of a, what's a going to be? Well, using the thing just up there again, what I can say then, is that a would be equal to 6 to the power of 4 there. So a works out to be equal to 1296. So if I did that, I'd get log 6t equals minus 2 log 6x, but plus log 6 1296, and now I can just try and combine everything using the log rules I know. So I would have that log 6t here is equal to log 6 1296, and then instead of having minus 2 log 6 to the x, I'm going to have minus log 6x squared. So I'm saying the power rule, that goes up there. And then obviously a log minus a log is the same as log 6 1296 divided by x squared. And the whole point about getting that now is that I can basically ignore the logs, take the anti-log of those two things. So I'm just going to get that t equals 1296 over x squared. So that's the answer. I'm just going to show you, I'll do it in a different colour, but I'm just going to show you a completely different method for doing it. Neither one is any better than the other one, I don't think, in particular. So what we could have done would have been to start with log 6t is equal to minus 2 log 6x plus 4. Don't do both of these methods, obviously. You can stop the video if you're happy with the other one, but just to show you this, I could just take this over to the other side. So I'll get log 6t plus 2 log 6x is equal to 4. Same thing, it's very similar in terms of some of the rules we're going to apply. I'm going to take this power up here, so I'm going to get plus log 6x squared equals 4. I'm now going to combine the fact that two logs added together is the log of t x squared is equal to 4. And then the same rule that we've been using all the way through here, if that's true, then t x squared would be equal to 6 to the power of 4. So t x squared would be equal to 1296. And obviously we're going to end up with the same answer here. 1296 over x squared. I don't have a particularly favourite way of doing that. Either one would be absolutely fine. Good to practice both methods, I guess, but in that case, neither of them is any quicker than the other one. Okay, nice log question. Hopefully that all makes sense to you.